Okay, so we are continuing our notes. This is 5.2.2, writing rules from real world problems. So we're going to take our idea of what we were doing before with slope, y-intercept, starts with grows by, and then we're going to learn how to do that with real world problems. And then on top of that, we are going to be using what we learned last week about systems of equations to solve the real world problems. So your essential question is, how can I use what I know about slopes and y-intercepts to write rules for real world situations? Go ahead and copy down everything you see on the screen here, then we will talk through it and do some examples. Okay, so when you're given a real world problem, which is going to be like a story problem, there are three kind of things that we need to know to be able to write our rules. Number one says we need to know what the X and Y variables stand for. So in a real world, we need to know which situation is going to be X and which is Y. The way that we know this is that we know, and we can highlight this, that the variable that changes on its own is which one is going to be X. And then the Y variable is whatever changes because X is changing. So that will make more sense when we get into a real problem, but X will always be whatever's changing on its own. And then Y changes because we're changing X. Then the second thing you need to know is in the story problem, what do we start with? And then how is the story changing or growing? So it's pretty similar to just kind of when we were writing, when I had you analyze rules, we still care about starts with and grows by, but now we're just doing it in terms of a real world problem. So your example for your right side is, we'll start here. Go ahead and copy this down. It says Dakota decides to start saving for a car. She already has $300 and knows that she can save $50 a week. Okay, so once we've got that down, we're gonna answer question one from our purple notes up there, which are what are the variables? So variables first. We need to know what is the X and what is the Y. Well, my notes say that X changes on its own. In story problems, most, not all, but most of them will have some kind of time involved. So how many years does it take? How long to finish the race? How many seconds? How many weeks? So that's your hint for your X is usually time. So in this story, I see the word weeks. So I know that my X variable is going to be weeks. And if we want, we could even add that up into our purple notes that usually X is some kind of time. So weeks, years, days, whatever. And then as time goes on, what will be changing in this story? So every week, what's changing in this story, it's the amount of money she has saved. So every week, Y, which is going to be money, is what changes. So again, the Y changes because of the X changing. We can't stop and start time. So X changes on its own, the week happens, and as the week happens, more money is saved. So the next thing we need to know in order to be able to write our rule is, what does this story start with? Well, I would probably go in my story and highlight some things. So she decides to start saving for a car. She already has 300. Whenever you see the numbers, go ahead and highlight them. So we have $350 a week are the important pieces of this. That will help us, right? She starts with how much money? Well, it says she already has 300. So this one starts with 300. And then the third thing we need to know is the growth. Well, that's your other piece we have highlighted that says 50 a week. So our growth is going to be 50 a week. Now that we know that, we can write our rule, right? We have y equals mx plus b. We know that m is grow and b is your starts with or your slope and y-intercept. So for this rule, we're going to write y equals, it grows by 50 and it started with 300. So there is the rule for Dakota. Okay, now we're going to do that same process again so that we can do as systems of equations. So here's the next problem. It says Murphy also wants a car. He has $500 and can save 25 a week. Copy that down and then we'll highlight the important information. Okay, so just like last time, usually the numbers are going to be the important information. So I see $500 here and I see 25 a week there. I'm going to skip labeling the variables for this one because they are the same as they are in Dakota's problem. So we're going to start with identifying the starts with of this rule. So what does this story problem start with? Well, this one, it says Murphy has 500. So it starts with 500. So then what's it growing by? That one's easy. It says 25 a week. So this one's going to be growing by 25 a week. So now we're ready to write the rule, and y equals mx plus b. We know m stands for how it's growing. We know b stands for where it starts. So Murphy's rule will be y equals, let's see, grows by 25, starts with 500. So that one is Murphy's rule. So that's half of this lesson. Half of this lesson is writing the rules. And then the next half is being able to answer questions. So now that I have the rules, we're going to answer this question. It says, using a graph, when will they have the same amount saved? So this is our systems of equations. We're going to graph both of our rules, and when they cross, that shows us when they have the same amount. So go ahead, and here's what I've drawn. This is the only graph growing on your right side, so use whatever space we've got left to make a graph. And this is where we use our variables. We've got X on the bottom and Y on the top. So the bottom is weeks, and the vertical is dollars. I went by 100s every line going up to 1,000. Okay, so if you have colors, that would be ideal. If you don't, it's okay. I'm going to write Dakota's rule up here so that I have it. It was 50x plus 300 was Dakota's. So let's graph that. You need to start with your starts with, that's that 300 there. So my first dot is going to go on the 300 for Dakota's graph. Now, normally I make you draw 4 quadrants, but because you can't have negative weeks, technically you can get away with the L-shaped graph here. Okay, and then Coda's rule says that every week she's going to add $50. So that's, if I scaled by hundreds, that's going to go by halves. So I can go here. It's going to look something like this. Every week, 50 more dollars. Normally I don't make you draw this many dots, but this one's pretty easy. And then we can go ahead, and this is why you all want to make your line nice and long, because we don't know where these are going to cross. We don't know how long it's going to need to be. So there's Dakota. There's her money. Let's find Murphy's now. So I'm going to use a different color for him. His rule was y equals 25x plus 500. So starting with the starts with, he starts with 500. So our first dot goes up on that 500. This one's a little trickier. He's doing 25 a week. So what I'm going to graph is every 2 weeks, he does half. So every 2 weeks, he gets 50 bucks. That will just make graphing a little easier. So technically, I'm going to have a little dot in between. Oh, wait a minute. I think I did that wrong. I started right and then I did it wrong. So I need to go over 2, up 50, over 2, up 50. There we go. Over 2, up 50, over 2, up 50. And I'm going to stop there because that's where they share a dot. But I also could have done it this way with these little dots in between, and then connect Murphy's dots. Make a straight line. This one was Murphy. Okay, so again, the question says, using the graph, when will they have the same amount? Well, here's where they cross. So to answer that question, it's going to be at 8 weeks. And in case we wanted to know money, $700. So that's the coordinate point, 8, 700, or 8 weeks, $700. So we made 2 rules and then we graphed them both and we're able to answer the question about when they crossed. So that's the end of our right side notes. So left side notes, we're going to do 2 problems, 2 graphs. So copy this down. It says Dakota has a pet fish that weighs 5 pounds and gains 3 pounds a year. Murphy also has a pet fish that weighs 19 pounds, but his loses 1 pound a year. So let's highlight our important information. So we've got fish that weighs 5 pounds and 3 pounds a year is important. Murphy's starts at 19 pounds, and that little LB stands for pounds, and he loses 1 pound a year. Variables, if we're going to name these guys, again, X is almost always some kind of time. In this case, it's going to be years, and Y is going to be the pounds of the fish. So years and pounds. So Dakota's fish, if we're writing a rule for Dakota, we need to know how it grows and where it starts. So we can write a rule. Dakota's grows by 3 pounds and starts at 5. So Dakota's rule would be Y equals 5x plus 3. So there's Dakota's rule. Ooh, I wanted that to be a circle. There we go. Murphy's fish, we need to know how his grows and where his starts. His is a little different. He loses a pound a year, so he grows by -1 and starts at 19. So Murphy's rule will be Y equals negative 1x plus 19. Then we graph these to figure out when they're going to weigh the same. So we should label our axes. This one is it years? It's not weeks, it's years. And this guy is pounds. Okay, starting with Dakota's. Hers starts at 3, grows by 5. I scaled by 2s, so starts at 3. Then plus 5, at 1 year it'll be at 8. Plus 5, 2 years will be at 12, let me see, 13. And maybe one more dot, 4 should be at 18, or 3 should be at 18. And then we can connect those. And either using colors or one thing or writing, we need to label it as Dakota's fish. Now we need to do Murphy's. Murphy's is gonna look a little different. Murphy's starts at 19 and goes down by 1. So my first dot would be where this 19 should go, and then just goes down. And remembering that I counted by 2s, it goes down by 1 each time. So his would look something like that, and then we would connect them to make a nice straight line. And again, either using colors or labels, make sure we know that that is Murphy. All right, this one's a little trickier. It's a little harder to tell, but they cross right there. That is almost at 3 years. I would say maybe 2.75. And then money-wise, that's almost 17, so we'll say 16.5. This is a test or a quiz and you can't tell exactly where it is, as long as what you've written down is reasonable for where that dot is. So this would be years, this would be pounds. As long as it's reasonable for where that dot should be, you'll get the credit for it. All right, last example problem. Copy it down. So this one says Dakota is learn. It should say Dakota is learning French. She already knows 5 words and plans to learn 3 a day. So I'm going to highlight what's important, which is 5 words and 3 a day. Then it says Murphy is also learning French. He knows 12 words and will learn 2 a day. So I'm going to highlight he knows 12 and is learning 2 a day. We're going to try to figure out how long until Dakota knows more words than Murphy. So our variables for this one, X is usually time. In this case, it's days. And Y is words, French words. So Dakota, we need to know her starts and her grows. Well, she starts with 5 words and she's going to learn 3 a day. So she is Y equals 3x plus 5. There's Dakota's rule. Did I circle them before? It did, so I'll circle it. That is not a circle. Okay. Murphy, we need to know where he starts and how he's going to grow. Murphy starts with 12 words and he's going to grow at 2 a day. So Murphy's rule would be Y equals 2x plus 12. Don't get those backwards. Now we're ready to graph and see when Dakota will know more. So I use the same graph setup as I did before. We should again give them a label. This time it's days and words. And we'll start graphing in either different colors. So I'll graph Dakota's first. She starts at 5. So my first dot should go right about there. Then she's going to grow by 3. So the next one would be at 8. 8 plus 3 is 11. 11 plus 3 is 14. Keep going in that pattern. 14 plus 3 is 17. And then 20. Maybe I stop there and connect those dots with a good straight line. Label that one is Dakota. And then we'll graph Murphy's. So Murphy starts with 12, but he's only learning 2 a day. So he's going to go a little bit slower. So every day it's plus 2 until they cross. And I maybe should have made this graph a little bit bigger. I'm going to need to go back and make Dakota's line a little bit longer. There we go. So it looks like they're going to cross right here, which is on week 7 or day 7. And it looks like it should be about 24, 26, right? 20, 22, 24. Yeah, I think it's 7, 26. So 7 days, 26 words. After 7 days, Dakota will know more words. So that is the end of your left side.